Everybody, this is Dark Guardsman. We're back. Now, I completely forgot to actually show off the simulation software in the last video. I'm half asleep and derping around, and I opened up the software as you saw in the earlier video, and was getting ready to show it off, and then I got off into a tangent where I was firing off the actual chemical explosion, which could be real quick here just to make sure you got a comparison. So I was firing this off and basically started talking about what I wanted to do with it, and I was showing off kind of from the above view of how the square-based pattern was emerging on the actual thing. We'll get a little bit over here to get another pattern here just to look at. And I completely forgot to switch back to the simulation software to show this actual pattern and work. Now with the simulation software, for those who haven't seen it before, it basically lets us do simple things like actually calculate different things like the path of the missile, the inaccuracy. It lets us see the data without actually being in the game in a much easier way that is a lot more understandable in various other things. I mean, there's tons of them, like we got red matter, we've got sine and cosine, we've even got a sine generator just to do kind of interesting things and be able to see stuff. Now, a new addition with this is being able to see the gas cloud render. And this kind of shows me how this actual render will populate the particles over time. For those who don't know how these actual renders work, is that this explosion actually does place a block in the, or not a block, places an entity in the world, and over time it'll tick every 5 ticks, so every quarter of a second, and it'll populate more particles in the world to kind of give us this cloud-like immersion. Main reason we even can get something like this is just simply the fact is there's probably a couple thousand particles being packed in a small area. Not the greatest for frame rate, of course, as I've noted at other times. But with the simulation software, I can see what this is doing, and hopefully in the future I can optimize this down to make sure that we can still get that same visual effect while making sure that the game runs well. And I'll go ahead and hit calculate here, and this is what we end up with result-wise. It's not the most easiest thing to understand. How this more or less works is that you have each colored dot representing a different randomization of the particles spawning, and every time you run this you'll get a little different layout, and we can sit here and look at this and see what's going on. Now with the start of the explosion, for a good period of time we got a big dense pack in the middle, and then as we go farther we get a much more broader range. Now the radius circle here, which I'm not sure if I'm actually drawing this perfectly correct because we got a lot of dots outside of it, this is supposed to represent the actual area of effect of the explosive with the black line. Now the reason why it's a oval instead of a circle is simply because of the stretching of the GUI. As you stretch the GUI, it'll stretch that out and everything else, and because my screen resolution is not perfectly in a 1-to-1 aspect ratio, it's more of like, I don't even know what it is, but it'll stretch it out and you'll get different things. So what this will do though is it will generate dots in a square pattern. It's supposed to clip the dots off once they get outside the radius in order to produce something. Something's gone wrong with how the math works, and of course because of that it does produce this pattern, and it's more box shaped as we saw in game. When I actually do fire this off, we get a very interesting box shape, and you can kind of see how it works out, and it does stay in a kind of a box pattern when it actually does fire. Unfortunately, I'm not sure I'm going to ever fix this because it works. It looks nice, it looks okay, and for the most part, you as a player or somebody else who's playing, say on your server or something, will get the impression that if I see this cloud, I should not walk towards it and actually get killed by it. It does a decent job at that. It's kind of nice. It looks good. It's got a nice randomization of color and everything else, but the math can at least show us what it's doing, and we can make predictions based off the math and figure out what's kind of going on and everything else. For those who actually do want to see the code, just if you're interested, let me go ahead and pop this open. The actual GUI stuff for this simulation system, it's incredibly simple. A lot of people have actually asked me how I do this and how would you clone it. It really is just a panel with a couple bits of data in it, and this is the actual part that calculates the data. This is ran multiple times, so if you do that little box over here, which you can calculate the number of runs, so say if we put this to 2 and hit calculate, it'll give us 2 runs over here instead of actually running multiple times. If we hit calculate again, we can actually see how this progresses. I do plan to kind of expand on this and let you do a min-max run, so you have like a starting point, max point, so you can look at individual points and everything else. But it's really meant for me to use, not you guys. But this will show you that, and when we go to the code, this will actually loop and run, and it'll generate a calculate data with a randomized color. It'll come down here, it'll figure out a center point, it'll then plot that center point so we can see that with a big dot. It'll then figure out a scale here. This is actually when we start seeing the code that does modify the actual point itself, is that with the actual explosive code itself, which go open that up just for comparison. Go down to Blast Chemical. It's called Blast Chemical. This is actually probably not what the original name is. This is probably something more like Gas Nerve something. It was in Chinese, so Don't ask me what it actually translates to. But the actual code that does run is it does spawn 200 particles. And then what it does is it creates a random point, and then it scales that point pretty much by the radius or call count. The call count is how many times we've actually looped through, and this runs every 5 ticks. So when we actually do fire, and this actually does run, this is what actually causes it to expand out, is when the call count goes up, and over time it eventually produces bigger and bigger particle, or it produces particles farther away. Now here's the check I was talking about that actually doesn't seem to be working properly, is these points should be spawning inside of the radius, but that's not what's happening. We are getting points that are more square based, and you can of course see this on the math itself, because the actual math as well for the panel does include that same similar check. Now of course it's two-dimensional because we are representing two-dimensional points on the chart rather than three-dimensional points in the actual blast, but the results are practically the same. We can see the same effect in game of the square-based pattern as we can see in the actual chart with the square-based pattern as well. And then to once rephrase it again for the last time, probably not going to fix this because it does work. It actually does produce a really nice and solid result. But there's the code. So there's the code that actually does generate the effects here. And here's the code that actually does the same thing. Pretty much identical for 1.1. And that's about it. So I'll see you guys with another video, and hopefully I don't forget anything else here.